Right, let's have a talk about ions, which are charged particles. Up to this point, you've only learned about atoms that have the same number of protons and electrons, making them neutrally charged particles. Ions are going to have a charge to them because one of the atoms has, well, an atom has either gained or lost electrons. They've been transferred to another atom. So when electrons are transferred, that causes a charge on that particle, on that atom, and therefore you have a charged particle, an ion. So why does this happen in the first place? We know that normally atoms are uncharged, they're neutral because protons and electrons are the same number. But this isn't always the most stable way for an atom to exist. So the atom's going to either gain electrons or lose electrons to get to a more stable state. And the way that they do that is they look at the number of valence electrons that they have. They're not stable if their valence electrons aren't either a number of 0 or 8. So they either gain to get up to 8 or they lose to get down to 0. And atoms are really lazy, so they do whatever's easiest. If they have 2 valence electrons, they will lose 2 instead of trying to gain 6 because that's more work. If you have 5 valence electrons, you're going to gain 3 instead of lose 5. If you happen to have 4 valence electrons, you're going to be kind of in between, and you might lose 4 or you might gain 4. But of course, some of those atoms don't always play exactly how we predict. So in general, we can say that atoms do its easiest to get up to either 0 or 8, which would be called an octet. Or if you are hydrogen and helium, you would get to 0 or 2, which would be called a duet. When the protons and electrons are no longer equal, that's when that charge happens because the pluses and minuses don't cancel. So it looks like this. For example, in magnesium, there are 2 valence electrons, and 2, it's easier to get rid of those 2, to dump those 2, and those 2 will leave magnesium, leaving it be 0 in that outermost energy level. What actually happens is the next energy level ends up having 8, which is a more stable way for that atom to exist. On the other hand, chlorine has 7 valence electrons. It's easier for an electron to come in from a different atom in order to make 8 valence electrons. So can these ions exist out on their own? The answer to that question is no. They have to have an opposite charged particle somewhere. They can't just be a negative charged particle floating around. That's not how that works. So a compound is formed. And a compound is going to be a neutral charge because all the pluses and minuses have to cancel each other out. So to do this, there's a couple of ways, but one way is to draw out the particles that we have to be looking at and then make the particles cancel by adding up your total positives and negatives. And if you don't have enough of one of the two, you add more of that particle in order to make the charges cancel. So it looks something like this. Let's say I was talking about aluminum and sulfide. So I have Al plus 3 particle, and I have a sulfide minus 2 particle. Now, if I look at my plus charges, I have 3, and if I look at my minuses, I have 2. So right now, I'm a little bit short on minus because they don't equal the same number. So S minus 2, now I have 4 negatives, and I have 3 positives, so I need more positive. If I add another aluminum particle, I now have 6 positives and only 4 negatives, so I need to add 1 more negative particle, and now I have 6 negatives and 6 positive. So there's 1, 2 aluminum ions, there's 1, 2, 3 sulfide ions. Because of that, I have 2 aluminum ions, I'm going to put subscript 2. Because I have 3 sulfide ions, I can put a subscript 3. Now, the other way to do this is called the crisscross method, where I'm taking my 2 charges and I'm putting them together. I'm going to take just the number, not the sign, and it's going to get put on the opposite charge, on the opposite particle. So my 2 comes down, onto aluminum, resulting in Al2S3, which is the same formula. Now you might be wondering, what if I had something like this, Ba2, and then O, negative 2, plus 2, minus 2 cancel. So I have 1 of each, so it's BaO. If I happen to have this in the crisscross method, and I crisscrossed, I would end up having Ba sub 2 and O sub 2. But because these two can both be divided by 2, I will reduce them down into BaO, like so. So now that we've been talking about all these particles, is there a way to name them? So Positive ions are also known as cations, not cations, cations. So they're positive because cats have paws. Get it? Anyhow, the element name is just going to be used with the word ion at the end. We don't change the name of the element when we come up with an ion. So calcium is how it's written on the periodic table, becomes calcium ion. On the other hand, negative ions, or anions, not anions, anions, N for negative, so you remember that. You're going to take the root word of the element name, and then you're going to add an IDE. So chlorine turns to chloride. Oxygen, drop the rest of the name, just keep the ox, ide. Sulfur turns to sulfide. And you can change any of those negative ions in that way. So at the end of this video, you should have learned why atoms react and why they form ions in the first place. You should have learned what a positive ion will be called, what a negative ion will be called. You should have learned how to come up with formulas for each of these, and you should have learned the numbers 0 and 8 to be stable numbers. Hope that works for you.